Hello, in today's video, we are going to take a look at Boyle's Law. Boyle's Law gives us the relationship between pressure and volume of a gas, assuming that we are at a constant temperature. So basically what we do is we take our combined gas law formula, P1V1 over T1 equals P2V2 over T2. Since temperature is constant, we can just leave that right out of the equation. Therefore, our equation will simplify to P1 times V1 equals P2 times V2. Now, it's important that we understand the relationship between pressure and volume of a gas. So if you think about a balloon, if you increase the pressure on it, you will be decreasing the volume. So the volume will vary inversely with the pressure. So since pressure and volume have an inverse relationship, our graph will have a negative slope and it will look like that. So as pressure increases, the volume decreases. One thing that's very important to point out is our graph does not look like this. So this is not what's happening. It is not a straight line down, because if that was the case, then there would be some volume, or sorry, there would be some pressure where the volume goes negative. And obviously we can't have negative volume. So therefore it's an inverse, not an indirect relationship, and it will just approach the x-axis, but it obviously does not cross the x-axis because we cannot have a negative volume. Depending on what math class you are in, you may have started talking about limits. So it approaches the x-axis, but does not cross that. All right, so we have our first example here. So we are starting with a 500 milliliter sample of a gas, and it's originally at 120 kilopascals. The volume is compressed to 100, so our volume is decreasing, and the temperature remains constant. What is the new pressure? So again, if we start with our regular formula, combined gas law, if we recognize that the temperature is constant, then we know that we can just leave the temperature right out. So therefore, that simplifies our equation, and now we only have 4 variables to work with instead of the normal 6 variables. So we are starting with a volume of 500 milliliters. The original pressure is 120 kilopascals. The new volume is 100 milliliters. So we also can use some common sense here. So if we take our gas and we smush it down to 100 milliliters, our pressure is going to have to increase. So we know that our P2 needs to be significantly higher than the original 120. So that just helps us out and make sure that we know that our math makes sense. So then we just do 500 times 120 divided by 100, and that gives us 600 kilopascals as P2. And again, that makes sense because since our volume decreased, we know the pressure will have to increase. Now, last step, we do have to do significant figures. Because of the 120, we need 2 significant figures. So therefore, we will do 6.0 times 10 to the second kilopascals. So since it was 600, that's a little tough to get into 2 significant figures. So therefore, we had to use scientific notation. All right, for example number 2, I will be doing my work right above that. So we are starting with 40 milliliters of a gas, and it is at standard pressure. So we're going to use one of the pressures off of table A in our reference table. We are looking for the new volume, and the pressure is changed to 1.25, and the temperature is held constant. So again, we can just do P1 V1 equals P2 V2. We can leave temperature out of the equation since it is constant. My first pressure is standard pressure. Now I need to use 1 atm, not 101.3, because my second pressure is 1.25 atmospheres and they need to match. And the first volume is 40 milliliters. Second pressure is 1.25 atmospheres, and the second volume is what I am looking for. So again, I can make sure that my answer makes sense. Since I am increasing the pressure, the gas is going to need to compress. The volume will have to decrease. So I need to get an answer that is less than 40. In order to do my math, I do 40 divided by 1.25, which will give me 32 milliliters. Last step, I do need to check significant figures. I need 3 significant figures, so I'd make this 32.0 milliliters.